All right, so let's say, for example, want to find the horizontal asymptotes. Clean that up some. Let's say for our problem A, you have f of x equals 2x over 3x squared plus 1. Say for problem B, you have 2x squared over 3x squared plus 1. And let's say for problem C, you have 2x to the third over 3x squared plus 1. Now here you can have 2x plus 5, you can have 2x squared plus 3x plus 7, you can have, actually change, let's say 2x squared plus 4x plus 1, just to kind of mix it up a little bit. And 2x cubed plus 5. Okay. Now what comes after the lead coefficient when you're looking for the horizontal asymptote doesn't even matter. Because in each case, you're just going to focus on those. Okay, so let's say for problem A, we have our f of x is equal to, instead of 2x, we can say that's 2x to the first power over 3x squared plus 1. Okay, so we know that this is our n, and this exponent is our m. Okay. So we know that n is less than m, since 1 is less than 2. Okay, so we know that just going back to our original sheet, when n is less than m, the x-axis is your horizontal asymptote. Okay, so we can see there that the x-axis equals our horizontal asymptote. Okay, does that make sense? All right. Any questions on this one so far? All right. Say for B, again, you have your 2x squared plus 4x plus 1 over 3x squared plus 1. Oh, probably should have made that a little lower. Okay, so we know that this is our n, and this exponent is our m. Okay, so in this case, we know that n is equal to m. So whenever your two exponents or your lead exponents are exactly the same, you're just going to make y equals those coefficients is your horizontal asymptote. Okay, now we do the same thing for C. You have 2x to the third plus 5 over 3x squared plus 1. Okay, so we can see there that that's our n, and this exponent is our m. Okay, so we can see that n is greater than m. Okay, so whenever n is greater than m, there is no horizontal asymptote. So any questions on that one? All right, I'll leave that up for a few more seconds. Okay, so far we've done the vertical asymptote and the horizontal asymptote. Now we're going to look at what they call the slant asymptote. Okay. Now to find the slant asymptote, you just use long division of polynomials, but you ignore the remainder. Use long division of polynomials. Find the slant asymptote. And ignore the remainder. Kind of clean up that G a little bit. All right, so let's say, for example, let's say for f of x equals x squared plus 2x plus 3 divided by x minus 1, find the slant asymptote. Okay, so that means that our x squared plus 2x plus 3 divided by x minus 1, we just rewrite it as x squared plus 2x plus 3 divided by x minus 1. Okay, so now we go ahead and do our long division. Okay, so remember the first thing we want to do is get rid of that x squared. So we have x times what will give us x squared, and in this case it's just x. Okay, so now we multiply x times x is x squared. X times negative 1 is negative x. So we multiply. Remember our next step is we subtract. So we subtract that entire term. That entire binomial. But remember, just a little reminder, negative x squared minus x, once you distribute, is negative x squared plus x, or plus 1x, depending on how you want to write it down. So x squared minus x squared is 0, so that cancels out like we planned. 2x plus x, because of the negative, is 3x. So we multiply, we subtract. Yep, now we bring down. Okay, so we multiply, subtract, bring down. So we have our plus 3. So now we want to get rid of that 3x. So what times x will give us 3x? And that's just 3. So we have our plus 3 there. So just like before, we multiply 3 times x is 3x. 3 times -1 is -3. Now we subtract. So we subtract those two. And remember, when we distribute that negative, this becomes 3x minus 3x, which is 0. And here you have 3 plus 3, which is 6. Okay, so that means we know that x squared plus 2x plus 3 over x minus 1 equals, nope, it would be our x plus 3 up there, x plus 3 plus 6 over x minus 1. Because that's just our denominator. Okay, so really we just ignore that. Okay, so that means that y equals x plus 3 is your slant asymptote. Leave that up for a second, then I'll show you the actual graph of it, so you can get a visual idea of what it would look like. Still writing. Let's bring that up a little. Alright, so if we actually looked at the graph, it will look like this. If you notice that our n is bigger than our m, so there's no horizontal asymptote, and x equal 1, remember that's where the denominator is equal to 0, that's our vertical asymptote. So if you look, you'll see that it actually never crosses that vertical line. And this is our slant asymptote, y equals x plus 3. So it'll never cross that graph. Does that make sense? Okay. All right, any questions on that one? All right. I'll put that in the scanned notes. Okay, so now we're going to look at, as you could say, story problems with rational expressions. So let's say, for example, let's say at 10 a.m., there are 115 performers. And at that same time, there are 1,200 spectators. At a music festival. Now, let's say at after 10 a.m., say 5 performers leave every 20 minutes. and 50 spectators. Leave every 20 minutes. Okay. Let's say we want to know, bless you, what's the ratio of spectators to performers at noon? At 12 p.m. Okay, so the first thing we want to do is we want to remember that a ratio, we can just write that as a quotient. Put that in fraction form. So a ratio can be written in quotient form. It's just a fancy way to say it's a fraction. Okay, so the first thing we want to do is we want to create our ratio of performers to spectators for our numerator and our denominator. So create an equation for the number of spectators and number of performers at 10 a.m. Okay, so that's the first thing you want to do. Okay, so your performers, okay, so if we look up where we actually started, there are 115 performers at 10 a.m. Oh, actually, that should be after 10 a.m. for this one. Okay, so that's after 10 a.m. So we started out with 115. And we see that 5 left every 20 minutes. So if we let our x equal our 20-minute interval, it's 115 minus 5x. Where x is the number of 20-minute intervals. Okay, we didn't quite calculate the intervals yet, but we know that every 20 minutes, you have minus 5s. So after the first 20 minutes, you'll lose 5. After the second, you'll lose 10, so on and so on and so on. Now we do the same thing for our spectators. Okay. We can see the same thing. We started off with 1,200, and we lose 50 every 20 minutes. So you have 1,200. Actually, instead of lose, let's say we add 50 spectators every 20 minutes. Kind of mix it up a little. Should have left that leave and erased that leave. So 5 performers leave. And 50 spectators arrive, just to mix it up a little bit. So since 50 spectators arrive every 20 minutes, say plus 50x. Okay. So our leave is going to subtract, and when they arrive, it's going to add. Okay. So that means that our ratio, our f of x, is just the ratio of performers to spectators. Okay. Now our actual equation for our performers is 115 minus 5x. And make that look like an actual 1. And for our spectators, 1200 plus 50x. So now we have our rational expression or rational equation. Now we have to actually solve it. So if you think about the number of 20-minute intervals, and from what, 10 to noon, you have 3 20-minute intervals from 10 to 11. Then you have another 3 20-minute intervals from 11 to 12. So from 10 to noon, you have 6 20-minute chunks. Does that make sense? Yep. So you just make your x equal 6. That's how many 20-minute intervals you have. So between, move that up a little bit. (10 a.m. and noon), there are 6 20-minute intervals, which gives us our x. So that's just a fancy way of saying let x equal 6. Let's clean that up some. Okay. So now that we know our x is equal to 6, you just go ahead and plug it right in. So 115 minus 5 times 6 over 1200 plus 50 times 6. Okay, so 115 minus 30 give us 85, and 1200 plus 300 is 1500. So if we divide both of those by 5, we end up with a 17 to 300 ratio. Okay, so that means you have 17 performers and 300 spectators at noon. Does that make sense? All right. So if you kind of break it down that way, it makes it a little less overwhelming. Okay. Any questions on that one? All right, I'll leave that up for a few more seconds. Oh, that's when we counted between 10 o'clock and 12 o'clock. They want to know how many 20-minute intervals there are. So there are 6 of them between that time frame. So if they said like 10 a.m. to 1 o'clock, then you have 9 20-minute sections. All right. Any other questions on this one? All right. Yes.
Was the placement of performers over perspectives just arbitrary?
Nope. Actually, when you, let me go back to the sheet there. When you see the ratio of performers to spectators, it's always going to be numerator to denominator.
Okay.
All right. Does that make sense? Yeah. Do that. All right. So for our next example,
It's like 26 in the recording. You might just want to stop and restart.
yeah, as soon as I write this, I was going to go ahead and let it go because it's going to shut off at 30 automatically. So thank you, though. So at 11 a.m., there are 400 members. Uh-oh. I'll do that on the next line. And say 159 members visiting a museum. Okay, so let's say if we have 10 members leave every 5 minutes, and 5 non-members arrive every 5 minutes. Okay, so what's the ratio of members to non-members? At 1 p.m. Excuse me. Give you a minute to finish writing that one down.